Hi students, welcome to Alpha C Learning Program Mathematics. In previous session we have discussed about some properties of focal chord, definition, everything. Still some are there here. Now read all of you this one. The circle described on any focal chord of a parabola as diameter touches directrix. Now observe here, this one is parabola, not only the standard form of parabola students, it can be any kind of parabola, horizontal, oblique, vertical, any kind of parabola if you consider. If a circle is described on any focal chord of parabola as diameter, it always touches directrix. See, sometimes whenever you want to do proofs for focal chord, you can just take the help of latus rectum also. Not necessary to take focal chord. One end is at square 2at and the other one is a by t square minus 2a by t, that is for particular y square is 4ax. One of the methods, students, suppose first method if at all you want to do, first we will consider standard form as y square is 4ax. Okay, to prove the first result. Standard form we are taking, and now suppose this is the focal chord you have taken, it is at square comma 2at, and you have to make use of the advantage of here focal chord. Then the other end is nothing but how much here, a by t square comma minus 2a divided by t. So this is the other end of focal chord we can observe, and this is our focus S of a comma 0. Moreover, S is not here exactly middle point of focal chord, provided it is a latus rectum. Okay, so now if you consider in this way, then they are telling that focal chord as diameter. That means these two are here end points of here diameter, and if you consider here a circle, and if you take a circle like this, then this circle as AB diameter always touches the directrix of that corresponding parabola. So this one only here they are asking. Now to do the proof here, actually you can go directly also, but to check actually it is not necessary, just you can make use of latus rectum. Okay, so one of the methods you can make use of this one, students, that means we find here x square plus y square minus x into sum of the abscissa at square plus a by t square, and next value minus y into sum of the ordinates, that is 2at minus 2a by t, and plus x1 x2 plus y1 y2 is 0. Okay, so if I write here equation of circle, it is plus at square into a by t square, and next value it is plus 2at into minus 2a by t is 0. So this is equation of circle having these two are end points of diameter, x square plus y square minus x into sum of the abscissa, and next minus y into sum of the ordinate plus product of abscissa plus product of ordinates is 0. And once you got this one, then the circle it has to touch the directrix. Now to this one, the directrix equation is how much? X is minus a. Implies we check here perpendicular distance from center of the circle onto this line is whether it is radius or not, and if it is radius, then we conclude the circle touches here directrix. So this one is the direct approach. Even then you have to take here the standard form y square equal to 4ax. And the other short method I am taking here, the short method is simply any proof whenever you want to take, just make use of latus rectum. Okay, so now here suppose you take parabola and the latus rectum exactly we are taking here, this is here L of a comma 2a, and this one is L dash of a comma minus 2a. Okay, so to the parabola y square is 4ax, we are taking here latus rectum because this is also here a focal chord. Now here exactly the middle point is nothing but this is focus, which is center of the circle. When you consider this is here diameter as latus rectum. Okay, now what about here, as this is the center and LL dash is our diameter, therefore this is nothing but what here, it is radius. Okay, so 2a here radius, and this one also you observe 2a as radius. Then now here once you know 2a is radius, vertically observe, and at the same time here also if you take this is, you know, it is the vertex 0 0. Then what about 2a? Here already a covered, then the leftover a value is exactly here. That means it is 2a distance, means you know clearly it is nothing but what here? Directrix. Therefore it is directrix where the circle, now if you take this one is here diameter, therefore if I draw the circle and now it is coming in this way. Okay students, that means clearly the circle is here touching which one here? That is directrix, because you observe this is how much here exactly? It is 2a distance, which is the radius. So perpendicular distance from center onto the line is nothing but radius. Hence you can say clearly this circle where end points of focal chord as diameter always touches directrix, particularly to the proof we have taken here latus rectum. So students, very important this formula. Whenever any problem is given, they give in numerical values, so then easily you can make use of the concept. So how they can ask here this type of value, how they can ask in our problems. So they will ask here circle described on focal chord of a parabola. Simply they will give equation of parabola like this it is, that is some x minus 3 whole square plus y minus 2 whole square is equal to some x minus 4y plus 5, and this is equation of parabola they will give. Understand? Then they will ask about here the problem as here find, that means here which fixed line touches a circle where focal chord is diameter. Understand? Now to this parabola, focal chord means don't think that you have to find focus and after that extreme points, everything not necessary. Just you can observe this is of the form SP divided by PM. Of course you have to multiply and divide by this whatever the requirement. Okay, and after that you can observe directrix is nothing but how much here? X minus 4y plus 5 is 0. Therefore here the circle which is described, suppose this is the oblique circle if you consider in this way, and now if this is the focal chord you got and this is our focus, and now here this is the directrix. So the circle by taking the ends of focal chord as diameter, now this circle clearly touches which one here? The directrix. Okay, so directly you can prove here the value that the line is nothing but directrix, and here it is nothing but what? X minus 4y plus 5 is 0. Okay, sometimes they give suitable conditions and thereby they ask, but finally what you have to conclude? The line is nothing but a directrix. Okay, now let us observe students, this is not a formula, just only a problem. The second one, so this one is given as PQ. It is a variable focal chord. Understand? It is a variable focal chord. What is variable focal chord means? Here suppose you take the parabola standard form only they gave, and this one is here a focal chord PSQ, right? And again we can say this is another focal chord, and next this is another focal chord, and again here this is another focal chord. In this way you can draw here so many focal chords. That's why they are telling here PQ is a variable focal chord. And now they are telling here vertex is A here, that means this is our capital A. Now they are asking about locus of centroid of triangle APQ. Okay, suppose this is one of the positions you have taken. This is one of the positions students if you consider. Now to this one the centroid is suppose G1. Okay, if I take here P1, Q1, and here centroid suppose it is G1. Okay, and next one the other position suppose you consider, that means suppose this is the other position P2 and next this one is the line Q2. Okay, and now again I am taking the triangle, that means if you join these, so this one is here the other part of triangle. Okay, this is the other part, and to this triangle again you can find centroid. So for this one if centroid is G1 and to this suppose centroid is G2, like that if you got centroids, then they are asking about here locus of centroids of triangle APQ. It is nothing but another parabola, and the question is what is latus rectum of that locus. Okay, so PQ is first of all what here? A variable focal chord, that means it is passing through focus, that is the common property, and every time if you take here different triangles, for each of them centroid exists, and if you join all such centroids, then the problem is what is the locus, and they are telling the locus is a parabola, but what about the vertex, the latus rectum. Okay, now let us fix here one of the points. Again here also you can make use of the latus rectum concept, that means, but it is variable chord given, so let's do directly. Okay, now I am taking here parabola, and suppose this is here our latus rectum, that is focal chord, and if P is 80 square comma 280, and you know very well it is the other point is nothing but how much, a by t square comma minus 2a by t. So here we are using the concept of focal chord. Whenever it is focal chord, then only we can make use of this relation. And what about this value here? It is vertex of parabola 0 0. Moreover, they mentioned clearly it is for y square is 4ax. Now let's join here these values, that is APQ. Okay, once APQ you join, and suppose here G is centroid, and whichever locus they asked, usually we consider that point as x comma y. So they asked about here locus of centroid. So let's take here centroid as x comma y. Then what about here centroid formula? It is 80 square plus a by t square divided by how much, 3. Okay, divided by 3, 0 is there, so plus 0 by 3, and the other point is here 280 and minus 2a by t. Okay, 280 minus 2a by t divided by 3. So that is our another value. Now here what is the parameter? T is our parameter. So we need to here eliminate this parameter. Okay, by eliminating the parameter you can obtain here locus. That means now onwards the problem is nothing but here elimination of t. Okay, now if I take equating abscissa, you will get 3x is equal to a into t square plus 1 by t square, and if you use here ordinate, that is 3y equal to 2a, if you take common it is t minus 1 by t. Okay students, now our interest is what here, elimination of t. For that purpose you can make use of here squaring both the sides, because t square plus 1 by t square is here, therefore I want to do here squaring both the sides. Then this is 9y square equal to 4a square, and it is t square plus 1 by t square and minus 2. Okay, now let us substitute here this t square plus 1 by t square here, that is 3x divided by a. So this 3x by a, t square plus 1 by t square, now I want to substitute here. So if you substitute the value here, 9y square is 4a square into what is the value, 3x divided by a, right, and minus this is 2. Now you got students exactly the form of which value here, it is nothing but a parabola. Okay, so this is exactly a parabola. Let us convert in standard form. X coefficient always must be 1 we are taking. To convert in the standard form, y minus beta whole square is equal to 4a into how much here, x minus alpha. So to convert into this kind of standard form, what is our requirement? X coefficient must be here 1, and here also we want to make inside the bracket y coefficient as 1. To that purpose, let us take here 9 value to the other side. Then y square is 4a square divided by 9. At the same time, let us take here 3 by a also outside. Then 3 by a and into x minus, what about this value here? 2a divided by 3. Okay, and now this 3 here 3 times and a here a cancel. Finally, you got how much here? Y square is 4a by 3 into x minus 2a by 3. Therefore, this is our lattice rectum, and in that lattice rectum position, you got how much here? 4a divided by 3. So students, finally, what is the locus equation we got here? The locus equation we obtained as y square is equal to 4a divided by 3 and into it is x minus 2a divided by 3. So this is equation of locus we got, and if you compare with the standard form, the length of lattice rectum is nothing but 4a divided by 3. Therefore, this is our right answer. So locus of centroid of triangle APQ is a parabola whose lattice rectum is nothing but 4a by 3. Now students, observe these two problems. First problem is here, AB is chord of a parabola y square equal to 4ax and with vertex at A as usual. This AB it is given. Okay, so the chord having one of the end points is here vertex. Okay, that is important thing. Now BC is drawn perpendicular to AB which meets axis at C. The projection of BC on axis of parabola. Now standard form only given in the problem. So first of all the problem completely based on diagram and later whatever requirements we got from our known concepts we can apply. So let us draw students here the parabola y square equal to 4ax. So this is the parabola y square is 4ax we got and AB is chord of parabola. Okay, so now here this is our axis of parabola we can observe. So this is axis of parabola and this is actually here chord of parabola, that means vertex of parabola, and they said here AB is chord, that means here this is one chord of parabola. So they said this is AB one chord of parabola and A is here we know this is 0, 0 and you can take this one as here AT1 square 2AT1. Okay, so one end I am taking AT1 square 2AT1 because this is a parabola y square is 4ax. And next one it is given, it is BC drawn perpendicular to AB. So a line BC drawn here perpendicular to AB, that means to perpendicular, and this BC line meets axis at what point actually here? It is meeting the axis at C. Okay, that means now this is the perpendicular line and meeting the axis at C. Therefore here it is right angle and now this point is here how much? C. Okay, so now this point we don't know, and next one is the projection of BC on axis of parabola. Okay, what is the question students here? The projection of BC on axis of parabola. Okay, now what is projection of BC here? On axis means we have to drop a perpendicular here and now this is exactly the perpendicular, so D. So what is the projection here? The projection is nothing but simply this part. So this is our requirement. What is projection of BC on axis of parabola? Then you have to drop a perpendicular from B exactly onto the line and then here this length is nothing but our projection of BC on axis of parabola. Here the axis is nothing but our x-axis. Okay. Now how to find this kind of value? So it is just basing on diagram only, nothing else. Now this is our AT square 280, so only one I am taking here 80. Now exactly perpendicular you have taken and this is the vertex, therefore this is how much students? It is nothing but AT square 0. Therefore these coordinates are here AT square 0. And next one here we don't know about this, I am taking this as on x-axis some value alpha 0. Therefore what is the requirement students? The requirement is mod of alpha minus AT square. So this is our requirement, mod of alpha minus AT square or mod of AT square minus alpha. So this is our final requirement. To obtain this one, we must make use of the concept perpendicular. Okay, because you have to make use of given condition. It is given in the problem that BC is nothing but perpendicular to AB. As BC is perpendicular to AB, therefore we must make use of that concept. So what is that concept here? If you take here BC slope, how much it is here? Slope of BC and into slope of AB is -1. So slope of AB and into slope of BC I am taking as here -1 and that implies the value is AB slope. What is that? 280 by 80 square. Okay. So 280 by 80 square and into slope of BC, that is 280 divided by denominator. How much it is? 80 square minus alpha. Okay, so this is 80 square minus alpha denominator and this is equal to how much? -1. Now we can cancel here students, this A value I am cancelling here and T square also we can cancel here. So what is the final value you got? 4a. Okay, 2 into 2a, 4a. Therefore, here you got at square minus alpha, that is alpha minus at square is equal to 2a, and hence here 2 into 2a, therefore the value is here 4a, and hence students finally you observe the requirement also how much here, our requirement is DC length. That DC length is how much actually? Mod of alpha minus at square. Therefore that value you got how much here? 4a. Simple. Okay. So what is the main thing in the problem we have used, students? The thing is, let B be any point on the parabola, parametric coordinates we have taken, and as the requirement is projection of this BC on x-axis, therefore we have taken DC is our requirement. And next one is here, from B, if you take a perpendicular onto the axis, it is exactly at square 0, because this is our vertex 0 comma 0. Okay, and next one, this is a point they said on axis. Again we are making use of axis concept where ordinate is here 0. So alpha comma 0, DC is nothing but mod of alpha minus at square. Again we have used here, these two are at right angle, therefore product of slopes is minus 1. And we used here the formula slope, and thereby you got this kind of result. So what is the answer, students, to this one? The projection is nothing but here 4a. Okay, and now let us observe the second problem, that is a chord PP dash of a parabola. Okay, a chord PP dash of parabola cuts axis of parabola at O. Understand, at O. O means here they didn't mention whether it is origin or anything, and moreover here they did not mention equation of parabola. Okay, they didn't mention anywhere equation of parabola. Implies, students, you can make use of this concept for any kind of parabola. Whereas here they have mentioned equation of parabola, that's why your answer is how much here? 4a. Okay, whereas here they did not mention anywhere equation of parabola. A chord PP dash of a parabola cuts the axis at a point O, and next feet of perpendiculars from P and P dash on axis are given as M and M dash respectively. If V is vertex, then what about these three values, in which progression they are? Okay, now again to prove this result, let us make use of here standard formula, that is standard parabola y square equal to 4ax. Sometimes while proving some results in circle chapter, we have used actually wherever center is origin, x square plus y square is r square, thereby our proofs will be very easily you can solve. In the same way here also we want to make use of y square equal to 4ax. Okay, now the parabola I am taking here, students, that is y square is 4ax. So this is the parabola y square equal to 4ax. Okay, now here they are telling chord PP dash of parabola. Okay, chord. In general I am taking not necessarily focal chord or anything, just like a chord I am taking here. This chord is here given as how much? PP dash. Okay, so this chord is PP dash. Anyways you can join this one. So I am taking here elaborately because more points are there, and now here the chord PP dash like this, because it is not necessarily you have to use here focal chord. So P, suppose if I am using 8t1 square comma 2at1. Okay, and then here this is P dash, this point we are taking as here at2 square comma 2at2. Okay, so this is the point I am taking. Q point or P dash point, it is nothing but at2 square comma 2at2. So we have used here concept of parametric coordinates up to now. And next one it is said here, that is this PP dash chord cuts the axis of parabola. If this is axis of parabola, students, it is cutting at which point they are telling? At the point O. Okay, it is cutting the axis of parabola at O. They didn't mention it is origin or anything, just at O. Now the feet of perpendiculars from P. So if I take, this is 1 foot of perpendicular from P onto which one they are telling here? Onto axis. Okay, onto axis. So foot of perpendicular from P onto axis, suppose here it is M. And next one, from here to here, what about this foot of perpendicular? It is nothing but M dash. Okay. So these are foot of perpendicular from P dash onto axis, and from P onto which one again? Axis of parabola. Okay. So now they are asking again here, they said V is vertex. So in general we are taking A, but here they mentioned V is vertex. And you know V for this parabola vertex is nothing but 0, 0. So V is vertex of parabola. And now the question is here Vm, Vo and Vm dash. Okay. Now this is origin, moreover this is our x-axis. Therefore let's make use of the advantage, that is this point is nothing but how much here? At1 square, 0. Okay. And next one, what about this point here? Up to this is At2 square. Therefore it is At2 square, 0. Okay. And next one, this O value, and all of you know students very well, this is nothing but chord joining 2 points. What is equation of chord joining 2 points? PP dash equation. So equation of PP dash is nothing but y into T1 plus T2. Okay, y into T1 plus T2 equal to 2 into x plus At1 T2. So this is our equation of chord joining 2 points. In previous session we have discussed, right? And now this chord is meeting x-axis. That means at that stage y is 0. That implies when y is 0, what about the coordinates here? It is 2 into x plus At1 T2. And hence students, what is x value? It is minus At1 T2. Therefore here these coordinates are nothing but minus At1 T2, 0. Okay. Now you came to know about all the lengths. What are the lengths we require? Vm. And the next length is how much? Vo. Okay. Vm is one length, Vo is another length. And what about the next length we require here? It is Vm dash. Okay. So Vm is one length, Vo is one length, and Vm dash. What is our Vm length? Vm length you got how much here? It is nothing but At1 square. Okay. And next one, Vo length. Vo means you can make use of here mod of the value, that is At1 T2. Okay. Mod of the value, or I am taking like this itself. And next one, Vm dash. And this length you got At2 square. Now you came to know clearly the square of this value, that is a square, T1 square, T2 square is nothing but how much here? Vm into Vm dash. Therefore students, what is the progression here? We can say the progression is nothing but here geometric progression. Okay. So what we have observed here? Vm is At1 square, and now here you got Vo square equal to Vm into how much? Vm dash. Therefore clearly these three are in the geometric progression. So this one actually you can make use of again one conceptual question, because nowhere here they mentioned the standard parabola equation. They just mentioned about what here? Just it is cutting axis of parabola. Okay. That means the parabola can be oblique parabola, vertical parabola, or horizontal parabola. Okay students. So finally what is the answer we got here? These three are here nothing but in geometric progression. Okay. Next one. Now sometimes students they give here some equation of parabola. Okay. So if they give a problem like this, that is if the line, okay, if the line Lx plus My plus n equal to 0, if the line Lx plus My plus n equal to 0, okay, meets parabola y square equal to 4ax. Okay, meets parabola y square equal to 4ax at two distinct points, suppose a comma b, at two distinct points a comma b. Then they will ask about here if the line segment AB, okay, if AB subtends right angle, understand, if AB subtends right angle at the vertex of parabola, right angle at the vertex of parabola, then they ask about some condition, understand, some condition on these a comma l comma m comma n. Okay. So what is the data students here? If a line if a line Lx plus My plus n equal to 0 meets the parabola at two distinct points A comma B, and if AB subtends right angle at the vertex of parabola, then conditions they will give, that is 4AL plus M is 0 or 4AM plus N is 0, like that some condition they will give on A comma L comma N. Okay, now how to do this one? This is actually not a new problem to us. Already we have done in our first year homogenization concept. Okay, now what is the data, students? Here our parabola is given, and this parabola actually here one line is meeting, this line is here. What is the line? Lx plus My plus n is 0. Okay, of course here n must be not equal to 0, and this is our y square is 4ax. Okay, and now it is meeting the parabola at A comma B. Now what they are telling here, this line segment AB is subtending right angle at the vertex of parabola. So this is here vertex of parabola. Suppose we take here, this is origin 0 comma 0. To this parabola vertex is origin. Let's take this point as suppose C. Now they are telling the segment AB subtends a right angle at the vertex. Then they are asking about here condition on A comma L comma M comma N. Okay, then the proof is nothing but, students, it is clearly the homogenization concept. Okay, so homogenization, all of you remember very well. This concept we can apply only when the point wherever the angle is subtending, it is exactly the origin. If the point is origin, then only we want to make use here, as this vertex is origin, and here these are the two lines which are at right angle. Okay, and therefore you know here this line we want to reduce as how much here? It is Lx plus My is equal to minus n, and then we write it as Lx plus My divided by minus n is equal to 1. That's why we used to say here this n must be always not equal to 0. And now here this is y square minus 4ax, and here this is second degree, and we want homogenization, implies you want to make here the degree is 1 at the same. Here degree is 2, whereas here degree is 1. So degree 1 at the same means here extra we require one more x value. So only 1 we write. Okay, and if it is exclusively constant, then we write as 1 square. Now y square minus 4ax into this 1 is nothing but here Lx plus My divided by minus n equal to 0. Okay, now what is the requirement? You got second degree in y, second degree in x, and xy again second degree. So completely you got here homogeneous, and if you simplify you will get of course a model ax square plus 2hxy plus by square is 0. But our intention is not the simplification of the complete equation, it is only objective, therefore we must make use of here right angle. Right angle means what is the concept here? Coefficient of x square plus coefficient of y square is 0. Okay, till now whatever the equation you got, students, that equation is nothing but combined equation of CA and CB. This is that equation, and the two lines are at right angle, therefore this is our condition. Now let's make use of the result. So here y square coefficient 1 and x square coefficient minus 4a into it is minus L by n. Okay, so 4a L divided by n. Okay, x square coefficient, and next y square coefficient, that is how much here? Plus 1 is equal to 0. Therefore if you take LCM, the result is nothing but 4AL plus how much it is? N is equal to 0. Okay, so this is our requirement, students. The condition they give options in terms of A, B, C and or A and LMN values. Okay, so x square coefficient it is minus 4a into L divided by minus n, minus minus get cancelled, so you got 4al by n. After that here xy, so no x square y square, and y square it is 1. So in this way you can obtain here this result, and the problem based on completely homogenization, right?